In this lesson, we're going to begin our unit on equations and solving equations. In this unit, we look at one-step equations, two-step equations, and multi-step equations. One-step equations we are already familiar with. We've learned this topic previously. We're going to start by reviewing this one and reviewing the process in solving one-step equations, because the process in solving one-step equations will carry over to two-step and multi-step equations. A lot of times one-step equations we can answer using mental math, so we don't like to follow the process. But it's very important to learn this process from the beginning so that we can carry it through the whole unit. So even though you feel like you might be able to do these with mental math, I want you to follow the process showing your work. Let's start by looking at a little warm-up example. X plus 2 equals 5. What must x equal, and how do you know this? So when you look at this equation, remember x is a variable which represents an unknown number. And because this is an equation, x is going to represent a specific number. So with expressions, you had to be given that number it equaled. But with equations, we can solve these equations to determine what that variable equals. And when we look at this one, x plus 2 equals 5, we know that x must equal 3. How do I know this? Because if I take x plus 2 equals 5 and I replace x with 3, 3 plus 2 does equal 5. So that's how I know that x must equal 3. And when we look at these one-step equations, we're going to start by looking at the equations that we can use addition or subtraction to solve. And then we'll move our way to multiplication and division. Now, before we start solving these, we need to review a few things. The equation above is known as a one-step equation and can be solved by inverse operations. Now, this term inverse operations, a lot of times you hear referred to as opposite operations. An inverse operation will undo each other. So let's think about our math operations: addition, subtraction, multiplication, and division. And let's start with addition. The inverse operation, or the opposite operation of addition, is subtraction. So these two operations will undo each other. And you have the two-sided arrow because it's vice versa. If you have addition and you want to undo it, you do subtraction. If you have subtraction and you want to undo it, you do addition. Then we have multiplication. The inverse or opposite operation of multiplication is division. And again, these two work simultaneously, vice versa, just like addition and subtraction. They're going to undo each other. So let's look at some examples of following the process of solving one-step equations. So the first thing you want to do is locate the variable. So you want to see if that variable is on the left side of your equation or the right side of your equation. Next, you want to determine the operation that is tied to the variable. So remember, when we talk about operations, that's going to be addition, subtraction, multiplication, or division. Then, step 3, you want to do the inverse operation on both sides of the equal sign in order to solve it. So in step 2, you've determined the operation. Step 3, you do that inverse. So in step 2, if you determine the operation as addition, Step 3, you would do subtraction. Then step 4 is to check your solution. A benefit of solving equations is you'll always know if your answer is right or not, because you can take your solution, plug it back into your original problem to check to see if you're correct. Let's start looking at some problems and looking at how we can apply these steps. Number 1, x plus 14 equals 30. So when you look at this problem, you might know off the bat or after a few seconds mentally that x has to be 16 because 16 plus 14 equals 30. And there's nothing wrong with being able to do that mentally, but we need to know this process because this process we're going to apply when we do two-step equations and when we do multi-step equations. So the first thing is to locate the variable. In this one, my variable is x. My operation that is tied to it is addition. Actually, let's write that over here. So that's step 2. We have addition. Step 3, use the inverse. So the inverse of addition is to subtract. So use the inverse operation on both sides of the equal sign to solve. So my inverse is going to be to subtract, and for this problem we're subtracting 14. So we're going to subtract 14 from both sides of our equation. As we're working, we're going to bring our variable down. So we're going to bring down the x. 14 minus 14 here. 14 minus 14 is 0. So those eliminate. So we don't write 0, we can just cross those out. Equals 30 minus 14 here. I'm reading it straight down. 30 minus 14 equals 16. So I know based off of my solution that x equals 16. So when we're solving equations, whether they're one-step, two-step, or multi-step, our goal is to get that final answer to say our variable equals a number. And in this example, number 1, we find that x equals 16. Now the last step is to check your solution. So what I can do to check it, I can take my original problem, which was x plus 14 equals 30. And after doing my work, I found that x was 16. So I can replace x right here. I can replace that x with 16 and say 16 plus 14 equals 30. And 16 plus 14 is 30. So I get that 30 equals 30, which is a true statement. So when I'm solving it, when I'm checking it, if I get that true statement at the end, then I know that my answer of x equals 16 is correct. Let's take a look at number 2. 2 plus y equals negative 4. First, we're going to locate the variable. In this example, my variable is y, which is here. Then we're going to determine the operation that is tied to the variable. In this problem, the operation is addition. Then in step 3, we're going to do the inverse. So the inverse is subtraction. And in this problem, we're going to be subtracting the number 2. So looking at the problem, we're going to subtract 2 from both sides. And if you notice, as I line these up, I'm subtracting that number from my numbers in the equation. I'm not subtracting it from that variable. 2 minus 2 here is 0. And again, we don't put 0, we just mark it out. And as we work, we continually bring down our variable. So y equals, and then here, negative 4 minus 2. So negative 4 minus 2 is negative 6. Because remember, when they're both negative, we add and keep the negative. So I get an answer of y equals negative 6. So another thing we talk about when we solve equations is the goal is to, what I talked about number 1, to get our variable equals a number. Another way we say that is that our goal is to get our variable isolated. We want that variable to be by itself. We don't want it to have any operations or any numbers on that side of the equation with it. We want it to just have the variable on that side of the equation. Let's take a look at number 3. Locate the variable. This time we're using the variable p. The operation that's with it is addition. So we're going to do the inverse and we're going to subtract. And for this problem, we're going to be subtracting 5 because 5 is that number on this side with our variable that we need to move. We need it on the other side so that our variable is by itself. So we subtract 5 from both sides. And then 5 minus 5 eliminates. Remember, we just mark it out. We don't put 0. We bring down our variable of p equals negative 18 minus 5. They're both negative, so we're going to add and keep the negative to get negative 23. So we find that p equals negative 23. And then we're going to check our answer. So starting with our original equation of 5 plus p equals negative 18, we're going to replace our variable with that value we just solved. So we're going to replace our variable with negative 23. So 5 plus negative 23 equals negative 18. Remember, 5 plus a negative, that's going to make it just a subtraction problem. So we're really doing 5 minus 23, which is negative 18 equals negative 18, which is a true statement. So we know that our answer of p equals negative 23 is correct. Go ahead and highlight number 4. And let's take a look at number 5 because it looks a little bit different. So number 5, when you locate your variable, you see that that variable is here on the right side. So it's in a different location. And that's okay. It's okay for your variable to be on the right side and not the left. We still want to follow the same steps. We want to identify what operation it is, and it's addition. The inverse of addition is subtraction. And in this problem, we're going to subtract 6. Because remember, we're subtracting the number that's on the side of the variable because we're trying to isolate that variable. So we're going to subtract 6 from both sides. And remember, the way we line it up, we're lining it up basically with our like terms. I'm not going to subtract 6 from k because I can't do that. 6 and k are not like terms. I'm lining them up with the terms that I can actually subtract them. So negative 6 minus 6, they're both negative, so we're going to add and keep that negative. 6 plus 6 is 12, and keep the negative. Equals, bring down the k, and 6 minus 6 is 0, so we eliminate. Remember, we don't put 0 down there. So now you can see your answer looks different. Negative 12 equals k. What we're going to do is we're just going to switch it. We're just going to flip-flop them exactly how they are, and we're going to write our answer that k equals negative 12. This is just a more mathematical way of writing your answer. It's one of those mathematical rules that we follow. Then we're going to check our answer. starting with our original equation, negative 6 equals k plus 6. We're going to replace our variable of k with negative 12. So negative 6 equals negative 12 plus 6. Remember, we're replacing that with negative 12 because that's what we found over here in our answer. Then we're going to solve it. Negative 6 equals negative 12 plus 6. So our signs are different here. So because our signs are different, we subtract. 12 minus 6 is 6. And keep the sign of the bigger number. 12 is bigger and 12 is negative, so we keep that negative. And we get a true statement. Negative 6 does equal negative 6. So by checking it, I know that my answer of k equals negative 12 is correct. Go ahead and highlight number 6. On the next page, let's take a look at number 7. We're going to locate our variable, and in this one our variable is y. In this one, our operation tied to that variable is subtraction. And then in step 3, the inverse of subtracting is to add. And for this problem, we want to add 5 because 5 is the number that's tied to our variable. So we're going to add 5 to both sides. Bring down your variable. Negative 5 plus 5 is 0, so remember we just mark it out. Equals 4 plus 5 is 9. So we get that y equals 9. Then we can check our answer. Starting with our original equation, y minus 5 equals 4. And then we're going to replace our variable with 9 because we found that y equals 9. So 9 minus 5 equals 4. 9 minus 5 is 4 equals 4, which is true, so I know I'm correct. Go ahead and highlight number 8, and then highlight 9 and 10, and let's take a look at number 11. Number 11, locating your variable, it's on the right. The operation tied to that variable, right behind that variable, we have subtraction. So the operation tied to this one is to subtract. But then in step 3, we're going to do that inverse, which is to add. And we're adding the number that's tied to it, so we're going to add 10. Remember, you have to do that to both sides. And we line it up with our like terms. So 44 plus 10 is 54 equals q. And then negative 10 plus 10 is 0, so we mark it out. But remember, when we get an answer like this, you want to just flip-flop it so that it says q equals 54. And then we can check that. Taking your original equation, 44 equals q minus 10, and replacing that variable with the value we just found. So 44 equals 54 minus 10. 44 equals 54 minus 10 is 44, which is true statement, so I know I'm correct. Go ahead and highlight 12, 13, and 14. And then let's take a look at number 15. So we're going to be doing this same thing, but what we have to do first is to translate it. So number 15 says that the sum of a number in 6 is 32. So our key words here are sum, which we know means to add, a number, so we've talked about that before, that's our variable, so that's x, and 6 is, we can translate that as an equal sign, and then 32. So when we write that out as an equation, what that's going to look like is x plus 6 equals 32. And once we have it written like that, Then we can just solve it like we did the ones before. Locate your variable, x. So we're going to subtract 6 from both sides. We're going to bring down the variable of x, and 6 minus 6 cancels out, equals 32 minus 6 is 26. So I get that my answer is x equals 26. But then we want to check it. So when we check it, we're going to take our original equation we wrote, x plus 6 equals 32, and we're going to replace that variable with the value we just found. So we're going to replace it with 26. So 26 plus 6 equals 32. 26 plus 6 is 32, equals 32, which is a correct statement. So I know my answer of x equals 26 is correct. Go ahead and highlight 16 through 20. And as you're doing 16 through 20, make sure you're paying attention to your key words. So in number 16, you have increased. So that means you're going to add. Number 17, you have the word difference. Number 18, you have less than. Number 19, you have plus. In number 20, you have some. In all of these examples, you have the phrase a number. Remember, when we have that phrase, that represents our variable. And in all of these, you have the word is. And is can be translated as equals.